Hi, my name is Kitawat Thongput. Now I'm going to present the chapter 4, the propeller and seesaw control project. This project is the one of the classroom project that has expect the work principle of the position of the beam. By the beam will mount with the motor propeller and will adjust the potentiometer as a feedback, and we have to set the another potentiometer to set the position of the beam and use the embedded system to control. Yes, as I show in this picture is show the potentiometer of this project. For this one is the potentiometer for the feedback control in the system. If you setting to the beam, used to send the the degree of the beam that have changed in the real time as the potentiometer as the voltage. And this one is a schematic diagram of the propeller control project. But we have two input as analog input for A0 and A1 for the set point and feedback from the potentiometer, and one output to control the PWM of the motor. This is a concept design of like this one is a flow chart of this project. Firstly, this system will start lead the input analog input as set point and feedback, and then we have to calibrate it to the degree, and then we find the error from the set point minus the feedback, and then go into the PID control and change it to duty cycle, and then go to lead again. It will work in the cycle. This one is a lab view block diagram. From lab view block diagram, I will start presented the timer. Firstly, I have created the timer on the top that used to set the time response in the millisecond, and then go on the middle from the left to right one. I start input the ADC input section from the LabVIEW MyReal, and then I calibrate it. I use the Relink sub VI used to remap the data from 0 to 5 volt to 0 to 360 degree, and then I have used the mean to mean the data input. Like I have to filter the data before, because the potentiometer have many swing, and then I have go in the block is called offset, used to offset the data. Like I have to select the point that I need it to be 0, and then monitor. And for the control, I use the PID control system. I use the set point and feedback as I calibrated input to the will be the input for the error to the PID. The length of the PID output length is from 0 to the 10,000, and then I use the output of the PID and relink it to 0 to 1 and convert to 1 to 0 and send to the LabVIEW MyReal PWM out. And this here is the sub VI, is the relink sub VI. I use the formula node to calculation the input to the new length in the new value. This one is the virtual instrument of this project in the LabVIEW. this one is the table of the tuning data. I have started the tuning data with the KC, and then until the 500 KC I get the best result. Then I select it, and then I try to choose next one TI, and I tune it and see that the best one of the TI is around the 0.01, and then I tune it to for the K for 3D, and I tune it 5 times, and the last time is the better one. These three values I will use in this project, and this one is a quick video result. And here is the end of this project, and thank you, and see you into the next chapter.